So hello everyone, I Raghavendra Singh welcomes you all in another video. So today we are going to cover DSA Unit 5. Our date is 20th of April 2026. Okay, so basically before this I have covered Unit 4, which you can check in the previous videos. So in this unit we are going to discuss majorly about graph. So you all know what is graph. इसका आज सबसे बढ़िया एग्जांपल है गूगल मैप्स. हाउ गूगल मैप्स डिसाइड दैट दिस वे इज शॉर्टर देन दैट वे. So this is all happens just because of the pointing nodes and all. So we will discuss about this. So there are some topics like application of graph, C representation of graph, transitive closure. There are some theorems like Warshall algorithm, shortest path algorithm, linked representation of graphs, Dijkstra algorithm, graph traversal method, graph spanning forest, undirected graph to their traversal, depth first traversal, application of depth first traversal, efficiency of depth first traversal, breadth first traversal, and minimum spanning tree, Kruskal algorithm, round robin algorithm. Okay, so let's discuss with like graph. Graph is all about connection link. What is graph? If someone asks, then graph is all about connection. Graph is all about connection. Graph is all about connection. So link of it like a map of cities. Think of it like a map of cities. A map of cities. Nodes. What is nodes? I will discuss later. Node and the road edges. Node is city and road is edge. Okay. What is node and edge? I will discuss. The correct them. Here is the simplified breakdown of the curve. So first discuss with basic and representation. We are going to discuss basic and representation. Basic and representation. So application of graph, we have seen graphs are used everywhere. Real life example, Google Maps, which I have told you. Location are nodes, roads are edges, or Facebook, people are nodes, friendship are edges. Okay. Now C representation of graph. C representation of graph. C representation of graph. In C we usually store graph in two ways. First, usually we store graphs in two ways. First is adjacency matrix. Adjacency matrix are two-way array where A1 means connection and 0 means no. Simple are two-way array. It's a two-way array where 1 means connection and A means no connection. Okay. And now second is adjacency. This was adjacency matrix. This is adjacency list. So basically adjacency list is an array of linked list. It's an array of linked list. Linked representation below. Basically adjacency list is an array of linked list. Okay. Now what is linked representation? Linked representation. So basically linked representation of graph. Each node has a list of all other nodes it's directly connected. Each node has a list of all other nodes it's directly connected. Simple, each node has a list of all other nodes it is directly connected. Each node has a list of all other nodes. Has a list of all other node. It's directly connected to it's directly connected. Okay. uh, it is like a contact list of your phone where each person name is a node. Simple, contact person of your phone where each person is a node. Okay, each person is a node and their friends are listed under them, and their friends are listed under them. Okay. And now paths and connectivity. Second is paths and connectivity. Paths and connectivity. What is paths and connectivity? So transitive closure. First is transitive closure. So what is transitive closure? Basically finding out if there is any way to get from point A to point B even if it takes many stops. So basically finding out there is any way to get from point A, any way. So basically any way to get from point A to point B, point A to point B, even if it takes many stops. Even if it takes many stops. Okay. Now next is Warshall. Just forget this. Now next is Warshall algorithm. Warshall algorithm. So basically Warshall algorithm is finding the quickest way to get from one node to another. A mathematical shortcut to find the transitive closure. It's basically a mathematical shortcut to find transitive closure. To find transitive closure. It quickly fills a matrix to show all possible connection between all nodes. It quickly fills a matrix. It quickly fills a matrix to show all possible connections between all nodes. To show all possible connection between all nodes. Okay. Basically a mathematical shortcut to find the transitive closure. It quickly fills the matrix to show all possible connections between all nodes. Now shortest path algorithm. Shortest path algorithm. So basically shortest path algorithm is finding the quickest way to get from one node to another. The quickest way, finding the quickest way to get from one node to another. To get from one node to another. One node to another. Okay. And what is node? I have already told you. For example, finding the flight with the shortest travel time between Delhi to New York. Okay. For example, finding the flight the quickest way to get from one node. So finding the flight to the Delhi to New York. Which flight will take less time and less money. Okay. And next we have Dijkstra theorem. Dijkstra algorithm. So Dijkstra is a name of any scientist, any computer scientist. So the most famous shortest path algorithm. It is the most famous shortest path algorithm. Most shortest path algorithm. It always picks the cheapest or closest next step. It always picks the cheapest or closest next step, or closest in next step. Okay, the most famous shortest path algorithm. Basically, all are the ways to find the shortest path. Okay, so this is one of the famous. It always picks the cheapest or closest next step. For example, how your GPS find the fastest route to your house while avoiding long distance. Okay, yeah. For example, is Google Map. It finds the shortest path to reach the home. And now let's discuss graph traversal, which I have discussed already. We have third topic, that is graph traversal. I think brightness is becoming very low, so let me use this one. Okay, graph traversal. I hope now it is visible. Yeah. So basically, graph traversal method to process visiting every city in your graph exactly once. Or as I have told you, traversal means visiting each node. So here node is city. So visiting each city in your graph exactly once. In your graph exactly once. Okay, now depth first traversal. Depth first traversal, DFT. So basically, depth first traversal is you go as deep as possible down one path before backing up. You go as deep as possible. You go as deep as possible. as deep as possible down one path before backing up. Down one path before backing up. Before backing up. Real life example. For example, exploring a maze by following one path until you hit a dead end, returning back, then returning back. So exploring the maze by following one path. Simple. Exploring maze by turning one path. Okay. Yeah. So now breadth first traversal. Breadth first traversal. I hope this is visible. Yeah. So breadth first traversal is you visit all immediate neighbors first. You visit all immediate neighbor first. Visit all immediate neighbor first. Then move to the next level. Then move to the next level. Move to the next level. For example, throwing a stone in water. For example, stone in water. For example, stone in water. Ripples spread out the closest points first. Okay, it ripple and spread out closest points first. Okay. Now there is also undirected graph traversal. So basically this is just means roads to go both ways. Okay, very simple. Now spanning trees. Fourth topic we had, that is spanning trees. So what are the spanning trees? The minimum connection. Spanning means the minimum connection. Spanning forest, a collection of trees that connects all nodes in a graph but has no loops. Basically, a collection of trees that connects all nodes in graph but has no loops. Connects all nodes in graph but has no loops. Minimum spanning tree. Now is minimum spanning tree. Okay, connecting all nodes with absolute minimum total road. Connecting all nodes with the absolute minimum total minimum total road length or cost. Okay. Now next is there is minimum spanning tree. So connecting all nodes with the absolute minimum total road length or cost. Now Kruskal algorithm. It comes in spanning trees. Kruskal algorithm. So basically Kruskal algorithm to find the minimum spanning tree. To find minimum spanning tree, okay? To find minimum spanning tree, you sort all roads by length and add the shortest ones first, as long as they don't create a loop. Okay. Simple to sort all roads by length. If we have to measure all roads length, then first we have to do add a shortest ones first. Add shortest ones first. Shortest ones first, as long as they don't create a loop. As long as they don't create a loop. Okay. Yeah. So for example, a cable company waiting to connect 10 houses with the least amount of cable wire possible. Okay, it's very simple, with the least amount of cable wire possible. So they will use Kruskal algorithm. Now let's discuss next topic, that is scheduling. So basically scheduling, in scheduling we know we have to study one algorithm, that is round robin algorithm. Round robin algorithm. I have also discussed it in the operating system lectures. So through often used in operating system in graph. It represents a fair way of visiting nodes or handling tasks in a cycle. Through often used in operating system in graph. It represents a fair way of visiting nodes. It represents a fair way of visiting nodes. Of visiting node or handling task in a cycle. Okay. So basically, through often used in operating system in graph, it represents a fair way of visiting nodes or handling tasks in a cycle. So in simple words I can say, like a teacher giving every student 1 minute to speak, one after the other in a circle. Okay, 1 minute to speak, then other. Okay. Yes. So yeah, this was all just scheduling. So just thanks for watching. And for these topics more in detail, you can watch Abdul Wari, which is the best educator for algorithms, I think so. So thanks for watching. Let's revise all what we have done is. So basically, firstly we have taken the introduction of graphs, then basic representation of graph, then we have discussed types of graphs in C, and this is the path connectivity, and then interpolation, that was the next, then Warshall algorithm and all, then spanning tree, then minimum spanning tree, connect to all nodes in the graph it has no loop. Kruskal algorithm, scheduling. In scheduling we have discussed round robin. Okay, so this was all. Also, we have discussed this Dijkstra, graph theory, and the first search, binary first traversal. So thanks for watching. Next time we'll see